In your final Excel lab, we're going to model with quadratic functions. On page 51 in your lab manual, we have our practice problem. Several balloons were blown up and released from the floor, and then we have a table of data. So the first thing that we need to do is identify the independent and dependent variables. I'll do a text box for my answers. In this case, the hang time depends on the circumference. And now we want the equation for the quadratic function that best fits the data. Circumference being my x's and hang time being my y's. So I'll enter my data. And then create a scatter plot. And then from this, we want the equation for the quadratic function that best fits the data. So if I right-click, I can add a trend line. A quadratic trend line is a polynomial trend line with order 2. Display the equation, display the r-squared value, and so here is my equation. Alright, what hang time will a circumference of 72 inches have? Well, let's get a set of prediction equations going here, or predicted values. So equals 0.0176 times my x value, which is my circumference, squared, minus 0.6536 times circumference plus 7.231. So click and drag all the way down, and I want to know a circumference of 72 inches, so in my circumference column I'll type in 72 inches, and there we go, 54.41 seconds. And then finally I want to know what circumference would produce a hang time of 6 seconds. So we do need to calculate both. You may or may not, when you do these, you may or may not be asked for both. If it doesn't specify to do only one, to find only one, then I would find them both. They may not both be reasonable. So let's see what we can figure out. We're looking for a hang time of 6 seconds. Well, I know from looking at my chart, one of those is going to be between 33 and 36, closer to 36, so we'll type in 35. That's going to get us pretty close. Unfortunately, I can't tell where the other one is from the graph that I have up here. So what we can do, since we don't have it, is we can try goal seek data, what if analysis, goal seek. We want our hang time to be 6 seconds by changing that x value and hopefully, like it did here, it found the one that we don't have. So one of them is that after 1 point, or with a circumference of 1.99 inches, the hang time will be 6 seconds. The other one, what if analysis, goal seek, set that to 6. And then the other one is 35.15. Now really, the only reasonable one here for us is this 35.15 inches. Our quadratic equations sometimes are not, like, it looks like it's a good model, but in the long run, when you look at other values, it might not predict them as well. Like, chances are good if you had a circumference of 1.99 inches, well, it's not going to stay in the air for 6 seconds. It should be much less than that. This is most likely better modeled with an exponential equation, but quadratics are what we're talking about, so that is what we are using.